Alright, in class I told you I would work out this problem. Here's a limit with a cube root. The idea here is the same idea we use with the square root, and that is we want to get rid of the cube root. To do that, we need to turn that numerator into a difference of cubes, much like we had to turn the square root one into a difference of squares. Now, I never remember how to factor a difference of cubes. If you remember that, then hey, go right to the formula and use it. Instead, I realized that, or just remember that if you have a difference of anything, that x minus that stuff will, in this case x minus y, will divide into it. I just never remember what the something is. And since I never trust my memory, even if I thought I knew what it was, I'd probably still go ahead and work it out just to be sure. And so to factor the difference of cubes, we just need to figure out what that something is. And the key to figuring out that something is long division. So we're going to start with long division. I'm going to figure out that something, divide x cubed minus y cubed by x minus y. So we'd start a long division, x minus y, dividing into x cubed. And if you remember anything about long division with polynomials, you know you should leave some space for the missing terms, for those terms that are in between those guys. Remember how long division works? We start with the x. Say, hey, x goes into x cubed how many times? And the answer would be x squared. Then we multiply. X squared times x cubed is x cubed. X squared times minus y would be minus x squared y. Remember dividing, so we have to subtract, so it's going to change our signs. Then we would bring down, but there's nothing to bring down, so we do the division again. X squared. X times what would go into x squared y? Or x goes into x squared y how many times? The answer would be xy. So again, we multiply. Xy times x would be x squared y. Xy times minus y would be minus xy squared. Again, we're subtracting, so we change the signs, and we're left with just x y squared. Now we can bring down the y cubed. And again, we go back to our x there. And say x times what would give me xy squared? The answer is plus y squared. Now we multiply. Y squared times x would be xy squared. Y squared times minus y would be minus y cubed. Remember, we're subtracting, so we change the signs. And of course, when you do that, you get a remainder of 0. Now, the fact that I have a remainder of 0 is our indication that x minus y does in fact divide evenly into x cubed minus y cubed. In fact, it also tells me then that x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. That's what we have right here. Now, the question you might be asking yourself is, why in the world did we do this? Well, remember, we wanted to take that cube root of x plus 4 minus 2, multiply that by something so that it becomes a difference of cubes. Well, now we know what the something is. Now we know what the something is. And so in this problem, we had the cube root of x plus 4 minus 2. In my formula, that cube root is taking the place of the x, the 2 is taking the place of the y. So now, just by using that fact that I need to multiply by x squared plus xy plus y squared gives me the thing that I need to multiply by to make that a difference of cubes. And so now we return to the limit. And so we return to the limit. And now we need to multiply by that expression that we've just been discussing. It should be the x squared, which would actually be cube root of x plus 4 squared. Plus x times y. So that would be 2 times the cube root of x plus 4. Plus y squared, which would be 2 squared, or just 4. And if we multiply one part of our fraction by that, then of course we have to multiply the denominator by the same thing. Now, you don't have to bother with multiplying in the numerator there. We already know that it's going to become a difference of cubes. Okay, I apologize for the television in the background if you picked any of that up. But hey, look at it this way. At least you got a free math lecture and a free lecture from Dr. Phil all at the same time. Okay, back to the problem. So as we multiply through now, again, as I mentioned before, the numerator is just going to become a difference of cubes. So we'll have limit as x approaches 4. The numerator is going to become a cube, so that's going to be cube root cubed, or just x plus 4, minus 2 cubed, which would be minus 8. And then that's all over x minus 4 times that other stuff, which is a real pain in the neck to write over. Well, actually, I should add, it's usually a pain in the neck. Sometimes you can just say a magic word and it appears. So now, simplifying the numerator, we'll have x minus 4. X plus 4 minus 8 will be x minus 4. So this time I really am not going to rewrite things. Since x plus 4 minus 8 is x minus 4, I can cancel those guys out. And now I have the limit as x approaches 4 of 1 over that expression, cube root of x plus 4 squared, plus 2 times the cube root of x plus 4 plus 4. And now it's just a matter of plugging in 4, because it is a limit now that's not 0 over 0, it's one that I can evaluate. So now we just work that out. It's going to be 1 over now when you take the cube root of 4 plus 4, that'll be 2. 2 squared will be 4. Again, cube root of x of 4 plus 4 will be the cube root of 8. So times, which would be 2 times 2 would be 4. And then finally, plus another 4. So we get our answer, which we're kind of working a little upside down here, but hopefully you can follow well enough, of 1/12. Okay, and so there we've now computed the limit as x approaches 4 of the cube root of x plus 4 minus 2 over x minus 4. We found out, hey, it's 1/12. Okay, so I know everybody wants to get out and try their own cube root problem, so I'll let you go.